All right. You guys ready? All right, let's finish this up. Then we'll talk about what's coming up for the final. All right. So, we're talking about competition, we're talking about niche space. All right? Because selection always wants to favor those individuals that have the least amount of competition. Why is that? It's because competition has a negative effect on our species, has a negative effect on both of our species. It's going to affect their growth rates, it can affect their carrying capacity. All right? So whatever happens, whatever evolution has favored, it's always aimed at trying to reduce the amount of competition with other individuals, with other species, and so forth. All right? So we introduced this idea of the niche. And what we're talking about now is the consequences of evolution, or what happens in response to evolution. And the first thing we talked about was what's up here, is you start with a fundamental niche space. All right? That's in the absence of competition, our species is going to use these resources. That range of resource let's get these larger. There we go. It's going to use this range of resources out in our environment. And you have to remember that a niche, this ecological niche, the Hutchinsonian niche, mind you, is the guy that kind of formally described it, it's n-dimensional. We can look at all of our resources that are out there. So you've got this species that is going to be able to use these resources, but then once you start taking into account all the other organisms that are out there and all the competitors that are out there, it doesn't actually use this niche. It says, hey, I can't use all of it because I'm going to be competing with individuals. So I'm only going to use perhaps this amount of it, because this amount means that I have the least amount of competition that occurs. All right? This is our realized niche. We have the least amount of competition that's going to occur there. So basically our niche space shrank. If you remove the competitor, yeah, it's possible our species now enlarges to utilize the full space. All right, so this is kind of a form of habitat partitioning or niche partitioning, where our organisms, our species, are going to structure their realized niches to try to minimize competition. And again, and this is just, temporary. You remove the competitor, our niche can expand. All right, and it can move. It can move on any axis. Maybe I depicted this as shrinking on both resource 1 and resource 2. Maybe it's only a shrinking of resource 1 axis. Maybe it's only a shrinking of the resource 2 axis, and so forth. All right? So that was number 1. That was what we had up on this slide, right up here. All right, fundamental realized niche. This was in response to competition. We had a reduction of our niche space to minimize competition. Second consequence of competition is exclusion. So we said 2 species cannot compete for the same limiting resource and coexist. All right? If they're competing for the same limiting resource, then one of them will win out. So this idea of the niche space really doesn't apply. We don't see a change because we've got 2 species maybe that are utilizing the same realized niche and only one resource is important, and whoever wins out is going to exclude the other. Our classic example is paramecium. All right, you can see this. You can see the exclusion that takes place, but you can also do it with like molds if you want. I don't know how many. So I'm sure some of you have like apartments here or living in a rental house, right? And then you're going to travel for the Christmas, and then it's going to stay mostly empty, maybe what you can do is do a little experiment. You know, you put a piece of bread out or some other food out, and you let mold grow on it, and you see that you're going to get a bunch of different molds growing out on there, and then you leave, and you come back a month later. There's a good chance that only one mold is going to exist on that food item. It's competitive exclusion. You had a bunch that started, but they're all competing for the same space, and it's a possibility that only one will win out. All right? So that's the second thing. And both of those, both our niche reduction, so our partitioning, all right, and our exclusion are all on these short ecological timescales. They're going to happen very, very quickly. You can actually see it. And in fact, with this niche partitioning, it's going to happen basically immediately. You're going to have, you know, organisms, let's say, feeding on everything that's out there. They see a competitor, and then they say, okay, this competitor is feeding on that set. That means I'm only going to feed on this set of food items. That's on our ecological time scale. On an evolutionary time scale, what we see is character displacement. And it's a little bit different than what this niche partitioning is. So with niche partitioning, we said we have our realized niche, you remove our competitor, this niche space can expand to the fundamental niche so that our realized is the fundamental niche because there's no competition that's happening. All right? With character displacement, what we have is that one resource that is our limiting resource. All right? That represents our fundamental niche, so our niche breadth here. All right? And then we introduce our competitor. So here's our competitor. All right. Where does competition take place? Well, it takes place in this region of overlap. All right. That region of overlap, that is where we are feeling competition. Now, selection always wants to reduce competition between species because that increases individuals' fitness. So, over evolutionary time, what we can see is a gradual shift, possibly, of our niche utilization of one of the species that ultimately results in less competition. So, over time, what we could see is separation. Oops, hold on, let me change my color. There's our competitor. Separation, so that our overlap is minimal to none. All right? This is called character displacement. And this doesn't just have to be like movement, directional selection. This could be something like this, where we're still going to utilize this lower extreme, but what we've done is had more of like a stabilizing type of selection that narrowed our niche breadth, but ultimately we're reducing our overlap. Now, this kind of looks a lot like our realized niche space, until I tell you that if we remove our competitor in this case, our organism doesn't shift back immediately. Natural selection caused that shift. And because it caused its shift, we have to rely on selection to move us back. All right? So you remove the competitor, our niche breadth stayed the same. Our location, our scale, everything stayed the same. If we're going to move, we need selection to do so. Whereas if we had this situation where we had partitioning, you remove the competitor, yeah, our niche breadth is going to immediately expand. We're going to increase our food item, our resource usage, and so forth. All right? So when we have character displacement, when we have this niche partitioning, it's not just a movement left or right on our resource axis. We can also have a compression or an expansion, perhaps, depending on what's going on. So Darwin's finches were a great example of character displacement and not niche partitioning. Because when you had individuals, the populations, isolated, these are birds that are feeding on seeds. The depth of their beak determines what kind of seeds they feed on, hard seeds versus soft seeds, large seeds versus small seeds, and so forth. I think you talk about it in evolution, maybe? It's in evolution, right? You talk about it in evolution, maybe even in the intro bio course, all right? But you have on separate islands, this is their niche breadth. This is their, what you would say is their fundamental, or probably more appropriate term is realized niches, because you have other competitors that are out there, all right? And you can see that their realized niches have substantial overlap. When you put them in competition, this is a problem. They both suffer, all right? And in this case, neither of them can really shift. Neither of them could partition their resources adequately to still fulfill their needs. So what has happened is selection has favored situations where we have changes in our beak size that allow them to utilize different seed sources. If you remove this population, Geospiza fortis, from Santa Maria and San Cristobal, this population doesn't move up. I mean, it could, given enough time, but it's not going to be immediate. We need evolution to move us. Same thing. If we remove Fulginosa, we don't see a replacement. We don't see that niche being filled. All right? So, niche space is under selection. All right? Selection is going to favor those individuals with no overlap. And then over time, our character displacement will become apparent because we're reducing our overlap. We're reducing our overlap. Now, the question is, did the realized niche or the fundamental niche change? And that's kind of that question to kind of get at what happened. Did we have partitioning or did we actually have character displacement? If we remove the competitor and our species now utilizes the rest of that fundamental niche, then we know it was partitioning. If we remove that species and they basically still say use the same resources, we know this is character displacement. All right? And then is it fundamental versus realized niche? Well, if it's our fundamental niche, all right, then, and we remove that competitor, well, maybe that competitor wasn't really even a competitor at that point. Now, here's the question, though. We go out and we sample a species, and we think we know two species that are competing. And then you go out and do that experiment where you remove the competitor, and nothing changes in our resource use. So you remove the other competitor and look at that second species, and nothing changes. Does this mean that they're not competitors? Probably. At least currently they're not competitors. Were they competitors in the past? Possibly. And this brings us to the idea of the ghost of competition past. This is an idea that kind of drew from Charles Dickens's famous story, or at least one of his famous stories. All right? And the idea is this. We have our organisms that have partitioned to utilize various niches in our habitat. And when we look at those species, when we look at the usage, it looks almost random. All right? So when you see it and it looks random, was this because it truly is random, or was it due to competition? Now, the ghost of competition past says it was competition. Competition happened in the past that caused our character displacement to minimize competition among all of those species. When we go out and look at our niche space today and remove those competitors, we don't see those changes, and it would lead us to conclude that no, competition is not structuring our community. But we're wrong because competition did structure our community. It structured it in the past. And what has happened is over evolutionary time, we've produced this character displacement so that we don't really have a whole lot of this competitive overlap. All right, so competition produced this character displacement in the past, and that explains what we see today, which is minimal overlap or non-competition. This idea may have led to adaptive radiation. So we talk about all those finches. All right, look at all the variation in beak size. What produced that? Well, you could invoke the ghost of competition past in this case. Competition between individuals that were foraging and eating the same types of food items was causing a decrease, causing a negative interaction for both individuals. So selection started causing changes in the beak shape to minimize that overlap, that competitive overlap. Questions? And I'll say, this kind of looks like a form of selection that we've seen. What form of selection does this kind of look like, where we've got selection for the extremes? Disruptive? Yep, disruptive selection. Is this disruptive selection? Ooh, maybe, maybe not. Is this disruptive selection? So, how many species do we have for competition? How many species do we have for disruptive selection? Just one. All right, two different ideas. Now, disruptive selection could possibly lead to character displacement. But as depicted on the board, this was more about our directional selection, kind of getting us there. If, though, we have a situation like this, all right, and you have a competitor, look at how much overlap we have. That's where competition's taking place. Now you have a situation where disruptive selection could produce our character displacement because this part's favored. That part's favored, and then this part's favored. So we have selection against the intermediate resource and movement towards the extreme. That could possibly lead to our radiation, adaptive radiation, speciation, and so forth. All right, questions? All right, summary of competition. Limited resources lead to competition between individuals. All right, hopefully you kind of already had an idea that was the case. This competition exists within our species. That was the basis for our logistic growth equation. And it's also between our species, so between species and in habitat. It's noteworthy that fitness is reduced for all competitors. So selection is always going to favor traits and adaptations that favor less competition. All right? And I guess that's kind of that other part. So niche usage shifting, generally adaptations, development of adaptations that reduce competition, allow exploitation of a different part of the resource space. Now, the ecological niche is central to competition. That's kind of defining our resource use space so that we can figure out what parts are going to be important for competition, what parts overlap with other species. Now, this niche space is based on the usage of critical resources, and that includes both our abiotic and our biotic resources, as well as our factors. So, you kind of take the law of tolerance and then you start adding in all the resources. That defines our ecological niches. Now, when we talk about these niches and talk about the overlap and overlap as a determinant of the intensity of competition, we can't ignore the effect of disturbances. All right? Because disturbances have an important role. They can reset communities, they can keep population sizes down, and that minimizes our competition. Or if we don't have a whole lot of disturbances, or they're not really frequent, they allow our population sizes to be large, which generally produces communities that have high competition resources. So kind of go back and link this to the R-selected species versus the K-selected species. It's kind of where we're at here. All right? Now, if we do have competition, if we do have this overlap of resources, what are the consequences of it? Well, we broke it down into immediate consequences and long-term consequences. All right? Immediate consequences included this shift to our realized niches, so partitioning. It included competitive exclusion if it can't do this, if it can't reduce its space to limit competition. All right, that's more of our immediate. And then our long-term effects were the development of adaptations that either increase competitive ability, leading to competitive exclusion, or adaptations that allowed our organism to utilize different parts of our resource curve, different aspects of our resource curve. All right? Those adaptations may ultimately produce and lead to this idea of character displacement. Now, coexistence of competing species is possible. All right? One way in which they could coexist is if our overlap is really small. In this case, this is pretty big overlap. All right? You're probably not going to get coexistence. Something has to change. But if you have a small amount of overlap, yeah, it's entirely possible that species can coexist. And then, just because we go out and we remove a competitor and nothing changes, doesn't mean that competition wasn't important. We have to remember that we're dealing with evolutionary timescales. Think back to one of the early terms, the principle of uniformitarianism. All right? The processes that are happening today have also occurred in the past at the same rate. This is the ghost of competition past. Competition that happens today happened in the past, and perhaps our competition is the reason why we see what we see today. It helped to structure our resource usage. It helped to structure our adaptations. Questions? All right, we reviewed a little bit more than what I said we were, but really the only thing that was new was this idea of ghosts of competition past. Knowing that competition does occur, it did occur in the past, and that may explain our niche space today. Questions? All right. Kyle's watching. I wonder if we filled up his last 4 pages of his notebook. All right. Couple of things. Ooh. Hold on, let me let's do this first. We do have our final exam, right? That's on Friday. And I had my class ask yesterday in lab, where do we stand with the IDEA surveys? Let's check it. This keyboard blows. All right. Put this up here. All right, this is my end of the IDEA evaluations. All right, so like you can see, my GS 1181 course is done. So I can see it now. 20% response rate. this is actually better than what Dr. Hyman had. Dr. Hyman actually gave time in her class for the students to pull out their phones and their tablets and stuff to do it in class. And I didn't do that, and I got 20% just. I did the same thing in years past, and it didn't change it. Anyways, let's see here. Here it is. We're at 90% right now. So 60 students, we're at 90%. All right. Pretty good, pretty good. And you can see that I don't know who has not done it. So if I just do the roster, it just gives me everyone that's here. And it doesn't say who completed it. So just so you know, I don't know who hasn't. Some people haven't, because we only had 90%, but you know, if you're shooting for that 3%, right, talk to people. Talk to people. So that's 6 students, maybe? Is that right? 10%? 6 students? So get on your friends, get them done. But yeah, good job, 90%. That's awesome. That's awesome. All right. We have a couple things. The quiz is live. It went live. Hopefully you saw it and you can study it. It's due at the end of this evening. And it's for a reason, so that you can view the answers tomorrow. All right? Same thing with problem set. So I made a final exam problem set. This is labeled homework number 3. I think final exam problem set maybe. It's listed as homework number 3. It's several problems. Went back to Hardy-Weinberg, all right, because that's on our exam. We've got some population growth equations. Again, all right, this is to give you practice doing these problems. Those problems will form the basis of part 2 of the final exam. All right. Now, with that homework, what I've done is I've also made a quiz attached to it. Those homework quizzes don't count as like your regular lecture quizzes. We actually have a point breakdown for homework and participation. That's where those fit in. All right. So I kind of look at it. Did you do it? Did you attempt to do it? All right. That's kind of how I look at those grades. With that quiz, you have 3 attempts for it, and it's meant for you to kind of work through the problem, and then you have 5 minutes to upload your answers, and then it should tell you which answers you lost points on. All right. So on these, each one is worth, I think, 1 point. So you can kind of figure out that if you have a fill in the blank that needs, let's say, 6 items to answer. I think that was one of the first ones. And you have, what's 1/6 point? What's 1/6? Whatever that decimal is, and you have almost all but that one decimal, you know you missed 1. Pay attention to rounding, all right? When I say round to a whole number, I mean round to a whole number. All right, if I say round to 3 decimal places, I mean round to 3 decimal places. I did kind of key in the answers, so if you didn't have that leading 0 before the decimal point, it shouldn't matter. But that's meant, I have that up there so you can check your answers. It's better to do this than for me to post the key, because I know that a sizable proportion will not do the work and instead download the key and look at the key and try to say, oh yeah, I know how to do that on the key, and then when the exam time comes, they're completely lost. You don't know how to do it. So have to practice, have to attempt to do that. The exam's in 2 parts, as I said. All right, part 1 is our multiple choice, multiple answer, true, false type questions. That'll include our definitions, questions just across the board. It includes our new material. I can't give you like a breakdown as to what proportion is new material, but what I can do, we had 2 presentations: the reproductive output, the reproductive effort, and the competition. So those presentations are going to have more questions pulled from them on average than ones that have already been examined. So here's an example. We did, let me look to see what else we had. We did let's say the lifespan, right? Lifespan, where we talked about senescence and aging and stuff, all right? I may have, on exam 3, had, 4 questions pulled from that for exam 3. I may have written 7 or 8 questions. Have 4 questions on that. All right. On the final exam, I might only pull one question from that, all right, over that material. But on this new material that we did on the competition, I might ask you I might pull 6 questions from this competition. All right. So in terms of the number of questions per presentation or per question set, yeah, there's going to be more on the newer stuff, but that's still just going to represent a small percentage of the overall questions. It's probably, the new material is probably going to be about 15% of the final exam points. That's about what I can tell you, about 15, 20% maybe. All right. Part 1 exam, as I said, is definitions, multiple choice, multiple answer, true, false type questions. You do have figures and stuff where I've made figures and asked questions about the figures. Those types of questions are there. You'll know, I'll tell you how many questions we have and how many questions you have and how much time you have. I should also say there may be some matching on there. If it's like, we've done some matching with terms, terminology, situations. Maybe I have a figure or give descriptions and you have to match up, types of curves or whatever. But you'll know how many questions, you'll know how much time you have, all right? And for the most part, those are all going to be like 1 point per question. Part 2 are all of your calculations. So these are ones that you'll need your calculator, you'll need a scratch paper, all right? And what I've done is you can have your equations ready. You can I would, personally, if I was studying, I would write out all the equations. Go through my notes, pull out all the equations that we went over, that we actually practiced on, all right? And write down what do I use this for? When do I use it? What is it telling me? And all that stuff is a great study. You can have your equations handy, but I will also have a sheet of equations that become available when the test goes live. So if you chose not to do that, there is a sheet that has all of the equations that we covered. I don't tell you what those equations are, here's the equation. So, like for example, I might give you m over n equals r over c. What equation was that? What's that? Mark recapture. Yeah. So that's all you get. You have to recognize what it is when you'd use it. Maybe for the growth equations, maybe I put, let's see here, lambda raised to the t times n. I don't tell you what it was equal to. That's kind of what you need to recognize. Okay, what was this equation? What was it telling me? What do I use it for? All right. Those, again, I will tell you how many questions there are and how much time you have. With those questions, since it is calculations, those are all fill-in-the-blank type questions. You will have to type in your answer. And again, pay attention to the rounding. For the most part, I've tried to make the answers so if you forgot the leading 0, it's not going to be marked wrong. But check your rounding. Round according to what the problem says. The points on those questions varies. All right, points on those questions varies because some of them, requested more information than others. All right, but I do tell you how much time, how many questions, and how much time you have. Both exams, their due date is 11:30 p.m. on Friday. All right, and fair warning, don't plan to start part 1 at 11 o'clock thinking you'll finish it by 11:30. Or then you'll start part 1 and then be able to take part 2. No. At 11:30, you can no longer start either parts. Plan your time accordingly. Total time, probably about the same, about an hour and a half, maybe 2 hours. So, it's not like we're going to have a 200-point exam. There will be a little bit longer, a few more points because we have some more content, but for the most part, it's going to be about an hour and a half to 2 hours. Maybe 2 hours, 15 minutes. We'll see. Once I get the questions and kind of work it out. I already have part 2. I already know how much time you'll have on those and how many questions, but uncertain on part 1. All right. Questions. Other questions that came up. Had a question on how to study, how best to study. What should I study? Should I focus on everything? Good question. You should study everything. All right. If you've been working through this class, as I told you, you should be doing, you should have been writing out in a notebook what's on the slides. Writing things out was like the first step of learning the material, and really helps retention. What I would do is, kind of review those notes, go through all of the notes once or twice, and then what I would do is, and this is something that I would do, is I would go back to the quizzes and the exams, and then look at the questions and find the answers in your notes. If you got it right, hey, that's great. You find that answer in your notes. All right? You're not just finding that one answer. You're also reading the material before and after it to figure out where it is where does it appear in the notes. All right? That's a lot of quizzes, a lot of exams that you can do this on. All right? If you really want to do it, really want to study, I would take the time to not look at the answers, but look at the question and then try to answer it using your notes and then compare your answer to the questions. But I know that's hard to do because it's multiple choice. So what you can do is kind of cover up one part of your screen that has, the check marks and whatever, however you do it. That's definitely a great way because it's a form of active learning. Memorization's more, it is more active, but I would consider it more passive because you're just reading and trying to memorize it and recite it to yourself. Whereas if you're actively getting into your notes and finding these answers, hey, that's a great way, especially the ones that you missed. All right? All right. Any questions on the final exam? No? We might have some in. So in the meantime, before the final exam, I've had a couple questions that came in, not necessarily related to the final exam. So first up, is there diaspore lab at the regular time on Thursday? Yes, it is. It is. So we've got lab today on Wednesday, lab on Thursday. We already know fitness is on Mondays and Tuesdays. It's up to Wednesday and Thursday. See if they're going to unseat the current winners right now, the current leaders. All right. Question 2 was how many quizzes are dropped? I dropped the lowest quiz. Again, that doesn't include the homework stuff. I dropped the lowest quiz and go from there. The grades are posted right now, the current grades. I received Dr. Skipper's lab grades. I'm going to get those updated when I get down to my office. So those will appear in Blackboard. I'm still waiting on Wednesday's grades, which I should have either later today or tomorrow. And once those lab grades come in, and once I get them into my grade book, I will update our current grades. All right, what I have for the current grades. Final exam can replace your lowest quiz grade. I'm sorry, not your lowest quiz, your lowest exam grade, which has the potential to significantly improve your overall course grade. It's possible, all right? If you did, let's say, all about the same, let's say 80, 85% on all 3 exams, all right? And then you do like an 80, 85% on the final exam, it's probably unlikely that that's going to have a significant effect if we replace one of your exams because they were all pretty close. But if your quiz grade was, let's say, a 60%, what I'll do is go ahead and replace the overall quiz grade with that final exam. Reason you don't normally say that is because the quizzes are only 10%. The exams are 20 and 25%. So replacing a 20 to 25% grade has a much larger effect on the exams, but it has happened in situations just like what I said, where all the exams were basically the same, where grade replacement resulted in like a 0.1, 0.2 change in the course grade, but swapping out the exam grade made like a 1 to 2% change. So I'll do that as well. All right, any last questions? Get to studying. It's a daunting exam. That's all I can say. Daunting exam. All right? And they both, you have to plan your time. You have to get the exams done. At 11:30, you can't start either exam after 11:30. I think I've set it up so after the exam, you'll get your score. And then we'll just see. My plan is over the weekend or on Monday, kind of release it so you can see what you missed on the exam. And if I forget to do that on Monday and someone goes in and checks and you can't access it, please email me. Just remind me that that's what I need to do. All right? All right, we're done. Minus lab and the final exam. All right? Yeah? Yeah. All right. That's about all the questions we have. You guys all have a good one. Make sure you study. Get some rest. I really wish we didn't have class today. Believe it or not, I really think you needed at least 2 days to kind of break before the final exams. That's one thing that I would recommend if we did it. Go to have classes on Monday and Tuesday and then take Wednesday, Thursday off and then start on Friday. No, not really. I never had that growing up either. We always had a weekend.
They always said they were supposed to have that, and then none of the teachers used it.
Dead week is no lab exams. All right, see y'all later.